we can also see here that depth, salinity, and speed are more related to the principal component number 1, and the temperature does it to the PC2. Also, I wanted to make a further classification of the stations, and I assigned them according to how close or how far to the glacier they were, and also according to their depth. And here I saw a pattern where the outer stations were more associated to the principal component 2, and the shallower station, the number 11, were most correlated to the principal component 1. Also, then I ran a best routine, and I figured out that the functional diversity was better explained by the oxygen, salinity, and the current speed. And these 3 variables are closely related to some processes and some dynamics of every glacial marine fjord. For example, when the glacier melts, there is a resuspension process in the ventos, and it can happen. It can turn out to be also sedimentary dynamics in the stations that are closer to the glacier. And so, given these results, I now want to go further in the analysis and evaluate current, sedimentation, and resuspension rates, so I can get a better answer. Some concluding remarks here is that alpha and functional diversity both exhibited a gradient from the inner to the outer part of the fjord, something that it has been registered and in many other fjords. Also, deposit detritus and filter feeders were the most abundant. Omnivory, surface, motility, and free living were the characteristics that more dominated in this community. And as I said before, these 3 variables are really important to elucidate the composition and assemblages. And so it will be really interesting to investigate these patterns of currents and resuspension rates. I must thank now some institutions like the Peruvian Ministry of Foreign Affairs and the Científica del Sur University, and also the APECS for letting me explain these results to you. Thank you very much.
Thank you, Bernabe. We have time for one question. So the question that we got was, is it a benthic or pelagic productivity-oriented system? And if you know if the pelagic system do exhibit the same distribution and traffic diversity as the benthic, is it like the same pattern or it's different?
Well, that's a very interesting question. Unfortunately, in this Makellar Inlet, there has been few research about the pelagic system, but it's one of the recommendations to go further in this component. But in many fjords, as may happen in this one also, happens to be a really important component. The benthic system more than the pelagic. The pelagic system might be influencing in the summer when there are some algal blooms, but I think the most important system here is the benthic.
Thank you very much. We're moving on. Maritz Schmidt from University Laval in Quebec. And Maritz is going to talk about automatic zooplankton species identification for the Greater North Water Polyminia region. Moritz, if you unmute yourself, the platform is yours.
Yes, thank you very much for the introduction. Can everybody hear me?
Yes, it's great.
Perfect. Yes, welcome to my talk on automatic zooplankton species identification. Yeah, I'm not going to repeat the rest. So let's start directly with a slide titled From Zooplankton Nets to Imaging. I'm not going to talk about the role of the zooplankton in the ecosystem much more, since Jordan already covered that part. Important to know is that zooplankton are traditionally caught using nets. So basically, yeah, you put a net into the ocean, and as you tow it towards the surface, you collect a zooplankton sample in the water column. However, that technique has several disadvantages. So since the 1950s, several different imaging systems have been developed, and for example, we can see two of those here. So that would be probably the most well-known, the VPR, the video plankton recorder from Woods Hole, or the UVP from Villefranche-sur-Mer. Our system, however, is called the Light Frame On-Site Key Species Investigation System, but we like to call it short LOKI, and that one was developed by the Germans at the Army. Here, a schematic of the LOKI system. Important to know is that our system features a concentration net, as you can see here. So different to the two systems I just showed on the slide before, we are concentrating down here the zooplankton to get rarer species and a better representation. So that's similar to some traditional nets. But then as the plankton goes through the net, we take images of the particles here in the camera system. At the same time, we have the system with SSD drive and so on, including environmental sensors here on the left-hand side. Here down here are the sensors. So we actually record real-time all the environmental parameters as we image the plankton continuously over the water column. So how does that look like? Here, for example, from a couple of cruises, we started in 2012. You can see here a traditional net on the right-hand side, and then the LOKI on the left-hand side in comparison. So here again the concentration net, and down here is a bit hidden. You can see it here. That's the camera. If we go to the methods, then as the title says, we built an automatic identification model, and that model is for the Greater North Water Polynya region, as I call it. So we have northern Baffin Bay, the North Water Polynya, but all the way up to the Lincoln Sea as well. So really far north and a bit here into the Lancaster Sound. And this automatic identification model, oh sorry, I clicked